Hello everyone. Right, in this step what we're going to do is look at factors, and for a lot of you it'll be the first time that you've actually seen factors. Now, when you multiply two numbers to give you a product, both the numbers that you've multiplied together are factors, and the resultant one is the product. So for example here we've got 3 times 5 equals 15. So the 3 and the 5 are both factors of 15. 15 is the product. So we refer to the 3 and the 5 as the factor pair of 15. Another way of thinking about it is that a factor of a number is a whole number that divides exactly into it. So if we use 15 as our example again, if we're going to look at the numbers that are factors of 15, the easiest way to start is with the number 1. Everything goes into, 1 can be a factor of absolutely anything. They mostly come in pairs, so you've got 1. 1 times 15 is 15. The next one you could try 2. No, 2 won't go in as a whole number. 3 times 5 is 15. 4, no, that won't go. And then when you get to 5, well, you already know that 5 is, so you can actually see that we've completed all of the factor pairs there. So what I'm going to do now is just model to you how I find factor pairs, and we'll just see different numbers and see if any learning comes from this. I'm going to start off with the number 12. Now again, the way I do it is always start with the number 1. 1 times 12 is 12. So I've already found 2 factors there. But let's think about 2. Yep, I would have 2 times 6 is 12. Go on to 3. 3 times 4 is 12. And then by the time the next number is 4, you know you've already got to 4, so hopefully you'll realise that you've done it all. So here, when I'm looking for factors of 12, I've got 1, 2, 3, 4, 6, and 12. And the reason that we say they're pairs is because that's the multiplication. 1 times 12 is 12. 2 times 6 is 12. 3 times 4 is 12. So just to remind you, the factor of a number is a whole number that divides into it exactly. Let's do another one. So the next one that we're going to try is 22. Again, it's the same step as always at the start. You go for number 1. 1 times 22 is 22. Then on to 2. 2 times 11 is 22. 3 doesn't work. 4, that doesn't work. 5 doesn't work. 6, no, that doesn't work. 7, that doesn't work. 8 doesn't work. 9 doesn't work. 10, no, that doesn't work. And then you get to 11. And as you've already got to 11, you know that you've basically completed it. So for this example, the factors of 22 are 1, 2, 11, and 22. The factor pairs are 1 and 22. 1 times 22 equals 22. And 2 and 11. 2 times 11 equals 22. And again, the thing that I'm going to keep repeating is that a factor of a number is a whole number that divides into it exactly. So another way of thinking about it is the number that you're trying to get to is that in the times table. So you'll recognise numbers. You'll recognise, once you know your times tables really well, that that's a number that's in the times table of a certain number. Now we're going to look at one that's a little bit different, and there's one thing that's slightly strange, and I wonder if you're going to notice it. So this time we're going to look at the number 16. Here we start just the same as normal. 1 times 16 is 16. Then we try 2 times 8 is 16. Then 3, no, that doesn't work. What about 4? 4 times 4 is 16. But what we don't do is we don't put another 4 because we're just repeating it. So even though we talk about factor pairs, you might have 5 factors. So here the factors of 16 are 1, 2, 4, 8, and 16. But the factor pairs, 1 times 16 is 16, 2 times 8 is 16, and then it would be 4, but then you would have to times that by another 4. So in this example, you've got 3 factor pairs, but you've got 5 factors. 1, 2, 4, 8, and 16. So let's think about how you could get things wrong. What misconceptions could you have? How could this all go terribly, terribly wrong? Well, the main thing is knowing your times tables. If you know your times tables, these become very, very easy. If you don't know your times tables, well, make sure that you've got a times table grid or access to a calculator or something like that. The next way that you can make a mistake is not acting systematically. When I say systematically, I mean you need to go in the same order every time looking for your fractions. Now, if you remember, every single one of these that I've done, I've started with the number 1, then I've tried number 2, number 3, number 4. And it's that way. I'll just model that again on the number 30 here. So 30, we would have 1 times 30 equals 30. 2 times 15 is 30. 3 times 10 is 30. 4, that doesn't work. 5 times 6 is 30. And then the next number would be 6, but because you've already come across that number, you know you've completed all your calculations. Now you see here, we've got 8 different factors. We've got 4 different factor pairs. If you were just to try and guess these or not work in a systematic way, say if you just started with 5 or started with 10, the chances would be that you would miss one of the factor pairs out. And that's something that we've got to be really careful about. The next way that you can have a problem is if you fixate on the fact that they're called factor pairs. So let's have a look at 25. So again, starting systematically, 1 times 25 is 25. 2, that doesn't work. 3 doesn't work. 4 doesn't work. 5 works. 5 times 5 is 25. Now here, we've got 1 and 25. 1 times 25 is 25. But here, yes, 5 is a factor. Its factor pair, you would have to times it by another 5. So that would literally be 5 times 5 is 25. Only 3 factors, 1, 5, and 25. So don't think, just because they're called factor pairs, that it has to be an even number. Now you can also use manipulatives to help you with factor pairs. So I've got here 1, 2, 3, 4, 5, 6 counters. And what this is showing here is 1 times 6. But I could also use these counters to help me find other factor pairs of 6. So now if I was to move them here, this is now showing 2 times 3. So again, we start off before. 1 times 6, shown by the manipulatives, or 2 times 3. Now obviously with larger numbers it gets harder, but it just shows you, just with a few counters, if you're finding it hard to visualize, always ask for manipulatives and use those. A question that you might be asked is, how do you know that you found all the factors of a number? So let me just model that for you now. How do I know that I found all the factors for the number 10. Again, we start exactly the same way that we've done every single one. We start off with the number 1. 1 times 10 is 10. 2 times 5 is 10. 3 doesn't work, 4 doesn't work, then I come to 5. Well, this is how I know I found all the factors, because once I get to a number that I've already found is a factor, because I've worked systematically, I know that 1, 2, 5 and 10 are all the factors of 10. Another question that teachers like to ask is, which number is a factor of every whole number? Hopefully by now you'll recognise this. I've chosen 13 as an example. Where do we start? We start with what number? Number 1. Every single example that we've had, the number 1 has been a factor. Any whole number, you can divide 1 into it. And if you remember, we were saying at the start, a factor of a number is a whole number that divides into it exactly. 1 is the only number that can always do that. So for this example, 1 times 13 is 13. 2 doesn't work, 3 doesn't work, 4 doesn't work, 5 doesn't work, 6 doesn't work, 7 doesn't work, 8 doesn't work, 9 doesn't work, 10 doesn't work, 11 doesn't work, then we get to 13. So again, we know that the calculation is complete. So the factor pair for 13 is 1 and 13. 2 factors, 1 and 13. The one number that can always be a factor of every whole number is 1. Now, just as an aside, when you get onto year 5 and 6, numbers that only have 1 and itself as its factors, they are called prime numbers. And they're a lot of fun, but you'll discover more about them in due course. What I'd like you to think about now is how we have possible sentence stems that we use. So if we are using words as well as numbers. So if we look at this sentence here, 20 equals 10 times 2. So 2 and 10 are a factor pair of 20. I'll say that one more time. 20 equals 10 times 2. So 2 and 10 are a factor pair of 20. That's the sort of way we would use it in a sentence in maths. Another sentence, 13 has 2 factors. 13 has 2 factors. Okay, so I think we've gone through that fully. One question for you, if you'd like to put the answer in the comments, that would be great. I would like you to find the factor pairs of 35. Find the factor pairs of 35. Thanks for listening, and I'll see you next time.